G'day team, welcome back to another video on calculus. So we've been doing a lot of work with our differentiation and our practice of differentiation. And remember, differentiation is finding the gradient of a tangent at a specific point on a curve. Now, we want to start applying these skills to a bunch of different sort of scenarios. So one of the things we can do is actually find the equation of the tangent that we're looking at here. Okay, so we would be able to find the derivative at this point, the slope of this point. But what about the equation of that straight line? Well, the equation of a tangent at x equals a, okay, is y equals the derivative at a. So we'd find our derivative using our power rule from the last video. X minus a plus the y coordinate of the point of interest. Now, if I'm comparing this to my equation of a straight line, I've got my slope, I've got my gradient, my slope. I've got x, I've got a horizontal translation, and then I've got a y value or intercept, and I've got a y value or intercept here. So they are very, very similar. Now, there are a few steps we want to look at to help us in these questions. So step one, I'm going to want to identify the a value that's being required in the question. I then want to find f of a, so substituting the a value into the function. Step three is find the derivative function, so using our power rules and all our skills from last video. Then I want to substitute my a value into that specific function to get the gradient at that point, and then sub all the results into my tangent function or my normal function. Now, we haven't seen that one just yet. We'll get to that in a moment, but that's also the same sort of steps apply there. So let's follow those points and let's have a go at finding the equation of a tangent. So f of x equals 3x squared plus 2. Find the equation of the tangent at the point 450. Now, a is my x value, so that is my a there. And f of a is the y coordinate. Now, sometimes you won't be given the y coordinate, so you put a into my function and we would get out my f of a. So I've already got my first two things down. Step three was find the derivative. So I'm going to write my original function, f of x equals 3x squared plus 2. Now let's find the derivative of this function. So from the last video and the power rule, we know the 2 comes out the front and multiplies the 3, so 6. And then the power of x drops by 1 to be that, just 1. And if I have a number by itself, we know that goes to 0. So my derivative is 6x. Step 4 is substituting my derivative value or my a value into my derivative. So let's do that. Let's find f prime of 4. Now that is just 6 times 4, which is 24. Now I have all the necessary information for my formula. So y equals f dash of a is 24, x minus 4, because that's my a value, plus 50. Now, I want to put it in the form y equals mx plus c. So let's expand out that bracket. Y equals 24x. Now, 4 times 24 is 96. So I've got negative 96 plus 50. That means y is equal to 24x minus 46. And that is the equation of my tangent. Okay. Pretty simple. Follow the steps and you'll be more than fine. Let's have a quick look at normals. Now, a normal to a curve is a line which is perpendicular to the tangent at the point of contact. Now, perpendicular, hopefully you know or remember that it means it meets at a right angle. So I've got a little diagram here. If I've got my tangent in blue, then my normal is perpendicular or at a right angle to that line. Now, the slope of a perpendicular line is the flip. So we take the reciprocal and we make it negative. Okay. You can go into a bit of a proof on that and have a look at videos on that. We're just going to take it as face value for now. So the gradient of a normal is -1 over the derivative of a. So we're still finding all the same things. We're just putting it in a slightly different spot. So let's have a look at another example. So find the equation of the normal to the function f of x equals 6x cubed plus x at the point 250. So step 1, find my a value. There it is. Step 2, find my f of a value. Substitute a into f of x if you need. We're given it again. Step 3 was find my derivative. So my original equation, my original function is 6x cubed plus x. That means f dash of x is 18x squared plus 1. Okay, now we want to find exactly where my derivative is. So we need to substitute 2 in to my derivative. That is step 4. So f dash of 2 is 18, 2 squared plus 1. Now 2 squared is 4. 4 times 18 is 72. 72 plus 1 is 73. So now we've got all our information. We've got f dash of a, we've got a, and we've got f of a. Let's substitute into our equation. So minus 1 on 73, x take away 2, plus 50. Now, again, we want to expand this out so we have it in y equals mx plus c form. So y equals -1 on 73x plus 2 on 73 plus 50. Now, doing that kind of fraction in your head is probably going to be a little bit tricky, so I've got my calculator next to me. So y equals -1 on 73x plus 3,652 all over 73. And that is my final equation of my normal. Now, my normal, you're more than likely going to get some crazy fractions and things like that. Use your calculator. Don't be a hero. Just plug away and you'll be more than fine. Good luck, and I'll see you in the next video.